In this classwork, we're looking at higher order roots. For any of these that say not to use a calculator, I'm fine if you need to use the calculator. Also, hopefully you have a list of common cubes in front of you, which will make some of these ones that say to do it without using a calculator easy enough to do by using the sheet. If I'm looking in that list of common cubes for what the common cube for 1 is, that would be equal to 1. Because 1 times 1 is 1, times 1 again is still 1. The common cube for 216 would be 6, because 6 times 6 is 36, times 6 is 216. For the cube root of negative 729, since it's a negative on the inside, it's going to come out as a negative. Then I have 9 times 9 would give me 81, times 9 would give me 729. So my final answer here is negative 9. Again, I don't mind if you use the calculator for these. It says to do it without using a calculator, but hopefully you have the common cubes there in your notes somewhere where you can just grab these answers quickly if they're all whole number integers. As opposed to these that ask me to find the cube root to the nearest hundredth, here I would have to use my calculator. So in the lecture I tell you how to use the x root y button if you'd rather do it this way. The way that I like to see it is by doing parentheses 10 to 100 to the power of 1 divided by the root number. In this case, since it's a third root, it's to the power of 1 divided by 3. If I put that into my calculator, parentheses 10200, parentheses to the power of parentheses 1 divided by 3, and parentheses, I get an answer of 21.687. Since it says the nearest hundredth in the directions, nearest hundredth is 2 decimal places, so we want to go to this decimal place. Since we're dropping something that's 5 or larger, that means we round up. So I drop that 7 and round up this 8 to a 9. When I go for the second problem, it's negative 0.66 and parentheses to the power of parentheses 1 divided by 3 and parentheses. I get an answer of negative 0.870. Since that third decimal place is something 4 or less, I can just drop it. This is the correct answer rounded to the nearest hundredth. When I try the final one, 0.045 in parentheses to the power of parentheses 1 divided by 3 in parentheses, I get an answer of 0.355. When I go to drop this 5, it tells me to round up that 5, so it becomes a 0.36 to the nearest hundredth. For problem 3, it asks me to find the value without using a calculator. Again, I recommend using a calculator for these. The way that I do them in the calculator is I put what's under the radical to the power of 1 divided by the root number. If I do that, this would tell me 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power, or 2 times 2 times 2 times 2, would get me to 16. That's why my final answer is 2. Here, this negative is going to stay with it. If I put into my calculator 3125 to the power of 1 divided by 5, because 5 is the index or root number here, it would tell me that 3125 has a 5th root of 5. 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 3125. Here I'm doing a 7th root. The good news is that whenever I'm doing a root of something that's 1 with a bunch of zeros, if the root number equals the number of zeros, then the answer is going to be 10. Here I have 1, 2, 3, 4, 5, 6, 7 zeros. So if I'm taking the 7th root of this, my answer is going to be 10. Since it was negative on the inside and it's an odd numbered root that's allowed, it just means my answer is negative. And again, you don't need to be able to do that off the top of your head. You can put in your calculator as negative 1 with 1, 2, 3, 4, 5, 6, 7 zeros, and parentheses to the power of 1 divided by the index or root number, 7. If you put this in properly, it will get you to that correct answer. When we deal with variable expressions, we're going to do the same thing that we did for square roots. The only difference is, when in square roots we divided by 2, it was because that was the index or root number. Here, in the first problem, we have a root number of 3, so we're going to take the current exponent 12 divided by that root number of 3, and that's how we get the final answer of y to the 4th. For part B, I'm going to split it up into two parts, the cube root of 125 and the cube root of y to the 6th. Cube root of 125, that's one of my perfect cubes, the answer is 5. When I do the cube root of y to the 6th, it becomes y to the 6th divided by 3, so my final answer is 5y to the 2nd. Here, when I'm doing a cube root of a negative on the inside, it means my answers are going to be negative. It's going to be p to the 15th divided by 3rd, q to the 21st divided by 3rd. So that's going to resolve to negative p to the 15 over 3 is 5, q to the 21 over 3 is 7. When I go to take the fifth root of y to the 30th, it becomes y to the 30 divided by 5, which is just y to the 6th. The fifth root of 243, again, is not something I'm expecting you to know off the top of your head. You can just do it as 243 to the power of 1 over 5. What your calculator should then tell you is that the answer is 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So 3 times itself 5 times gets you to 243. That's why the fifth root of 243 is a positive 3. If I then do the fifth root of y to the 60th, it becomes y to the 60 over 5. So my final answer is 3y to the 12th. When I do the fourth root of x to the 36, it becomes x to the 36 over 4, which is just x to the 9th.